Good morning, good afternoon, good evening, wherever you may be in this part of the world. Welcome to another session of my presentation series. And this time, I have a nice topic, and that is understanding the application of combined instrument transformer. So, this is an instrument transformer that has both the current and the voltage transformer all integrated into the same equipment and has numerous advantages, and I will talk about it. Okay, my good name is John Kweku Amuotu, and I've been a professional electrical engineer for the past 31 years, and I've been practicing in the United States of America for the past 31 years. Okay, so now let's talk about basically, if you watch my YouTube presentation, don't forget to subscribe, to my channel. Below is my channel, and has numerous of presentations for you as a young engineer, development engineer, mid-career engineer, experienced engineer, consulting engineers. And as an experienced engineer, consulting engineer, this can even be a quick refresher for you. And if you like the video, the presentation, don't forget to select the like button. Then don't forget to share. Okay. Now let's talk about the functions and applications of the combined voltage and current transformers. Okay, so basically it is utilized up to voltages of 145 kV. That is, I'll say that 115 kV and with a maximum voltage of 132 kV all the way up to 145 kV. That's basically its application now. And its goal is to scale down voltages from 115 kV to a secondary voltage of 115 volts, and that is line to line voltage, and line to neutral voltage of 69 volts. And for current, its goal is to scale currents all the way up to 5,000 amps to a lower current value of either 5 amps or 1 amps, and basically mirroring devices, revenue mirroring devices. That is its main purpose. And sometimes, protective relay devices that will need this signals, both voltage and current. Okay, and just to rephrase what I made mention in earlier on, it is ideal for installation at the measuring point, and because of its inherent, inherent means internal attribute of high accuracy in voltage and current. So a lot of times you see it in the substation. You see it right at the entrance of the substation, and that is where they are mostly installed. Because of their excellent attribute in revenue mirroring. So it also has an excellent frequency response. So basically, if there's a frequency drift on your power system network, right, it's able to basically provide respond and provide accuracy measurement based on the frequency response. So it's able to basically to be used for power quality measurements and also for harmonics measurements. Now let's talk about the components, of the combined instrument transformer. It has a high voltage terminal. So the high voltage terminal basically is both voltage and current. And I'll show you a picture of basically how the high voltage connection is integrated through the power system network. Okay, so you'll see that a lot of times, most often than not, the high voltage side is a bar type, and because there's a reason behind utilizing that bar type, and sometimes you see a bar and basically integrated to the tubular bars, right? It's because of its inherent short circuit capability and also to prevent voltage drop, because if you have to use basically a conductor, can have a voltage drop, and that will result in you not measuring the right primary voltage and also primary current. Okay, so you see that it has a CT bushing, right? Okay, because it is a combined instrument transformer, so it has both the CT bushing and the PT bushing. So the CT bushing is integrated to a pipe that basically runs a vertical, and that is integrated to the secondary terminal box, right? So that is where you have your 5 amps secondary current or 1 amp secondary current to whatever, for you to integrate whatever revenue metering, voltmeter, or current ammeter that you want to integrate to the secondary terminal box. It also has a VT bushing, right? That also has high voltage cables that is integrated, and that helps it to be integrated to the high voltage transmission system. And the high voltage cables are very short, and within the instrument transformer. The low voltage terminals is at the bottom, right? And the CT core. Okay, so on top, right on top, you see an enclosure which is hermetically sealed. It has both a core and a winding for basically measuring the primary side current and also the scale down secondary current of 5 amps or 1 amps. Then it also has a VT core and winding that is located at the bottom, right? So that is the difference. The core and the winding for the CT is located on top, and a core and a winding for the VT is located at the bottom. It also has some oil, which is basically used for insulation system. And sometimes you can have a combination of oil and paper, and internally, basically to grade, it forms a capacitance, graded capacitance to basically grade, the voltage and electric field to prevent damage to the equipment. It's also hermetically sealed, and hermetically means that it is sealed tight and has no to prevent basically external weather elements from intruding, basically if you have moisture and other weather elements intrude, basically it will end up degrading and basically impeding the performance of the insulation system, right? Because for instance, if you have a moisture intruding into the oil, right, it is going to degrade the capability of the oil to be able to perform its insulating capability. Externally, basically the insulation system, insulation system, you have an internal insulation system, then you also have an external insulation system. So the external insulation system is basically can either be a porcelain or composite silicone material or polymer. And sometimes we have depending on the philosophy, also because the silicone external insulation system costs more than the porcelain. Like I said, each has its own advantages and disadvantages. Right? Okay. Then also you have an oil level. If you're using an oil as an insulating system medium, right, you need to basically be able to have an indication window, basically that has some bellows and indicator to tell you your oil level, so that if your oil level drops, then you can basically fill up the oil to the right level. They say pictures are worth more than 1,000 words. That it's basically the slogan that has been utilized that our philosophers basically tells us, and that is perfectly true, right? Pictures are worth more than 1,000 words. I can write 1,000 words on this slide, and sometimes you'll be scratching your head and basically what is this? What is this? But I have a picture here, beautiful picture, and basically right on top, this enclosure is aluminum, right? So that's what you see over here, right? pictures are worth more than thousands. That's quick control, right? Okay. So you have a top cover, right? And an oil indicator, right? So on the other side, you see the oil indicator. There's a window there that tells you your oil level. Then you also have steel bellows that are inside. And what those bellows is basically they helps you to expand the oil inside, right? During hot water, the oil inside expands. So there should be a way to accommodate those expansion. So that is when you use those bellows. And also, on the other hand, during winter time, right? Okay, it contracts, right? So the bellows should be able to, the oil contracts. The bellows should be able to contract, to accommodate the contraction of the oil. Next is the high voltage terminals, right? Okay, so you see that the high voltage terminals is right here on this side. Okay, this is the top cover, and inside you have the oil indicator right on the side. It's on the opposite side. You probably won't see it from the side. It has a window and it has the oil level, right? And inside you have the steel bellows, and those steel bellows, like I said, its goal is to basically expand and contract based on the ambient temperature conditions. During summertime, peak loads, right? The oil expands. So the bellows should be able to expand to accommodate the expansion of the oil. On the other hand, during winter time, it contracts. Then basically the bellows should be able to contract to accommodate the winter peak loads. Okay, so you have a CT cord right here, right? Okay, and a winding. So basically you have a core and a winding where basically you are able to achieve the secondary scaling down of the current transformer. So you have let's say high current up to 5,000 amps, and you're scaling it down to 5 amps or 1 amp. So you have the CT core basically that provides the magnetic path or magnetization branch, right, to provide the magnetic flux that basically creates the induction of current. Next is the high voltage insulation, right? Okay, so inside you have oil plus paper, right? And I'm indicated that you sometimes utilize a combination of that to form graded capacitance, where basically the graded capacitance, the goal is to basically to grade the electric field, right? So that you wouldn't have a high electric field that would degrade the internal components of the insulation system. Okay. So externally, you also have an insulator, right? And I indicated you can either have a porcelain or composite. Okay, so this is this insulator over here, external, right? Okay, and in my previous videos, I explained the reason why they have this, right? This formation for the external insulator, right? Okay, so the goal is, if you have a substation, right, and this instrument transformer, combined instrument transformer, is located in a contaminated environment, let's say for industrial facilities, refineries and all those things, they emit a lot of, oil waste, contaminants, dust into the atmosphere, and if you have a facility that is close to the ocean, you can have a salt mist, right? All these are basically formed on the peripheral surface of this external insulation, right? Okay, so with time, basically leakage currents start flowing on the surface, of this. And basically, as the level or the magnitude of contamination increases with time, right, the leakage current, the magnitude of the leakage current also increases, right? And basically, if you don't have the means of extending the creepage distance, then you'll have a flashover. Yeah, because the distance to ground is short, right? Okay, so this is a way of extending the leakage distance to ground. So that is why you have this zigzag movement, so that it makes it very difficult for the leakage current. You extended that distance to prevent flashover. So next is the secondary terminal box. Okay, so the secondary terminal box, this is how it looks like. This is where it is located. Okay, right? Okay, so for the secondary terminal box, you'll see it on both sides, right? Okay, one on each side. So as you can see over here, you also have the high voltage and the low voltage VT winders. Remember, I made mention that on the top, right here, right, you have the CT, core, and winding. On the lower portion, you have the VT, core, and winding. Then below that is the magnetic core, the VT core. So that itself, it's located over here. And now on top is the CT. So most often than not, in maintenance of this combined instrument transformer, right, you need to sample the oil depending on where it is located. It's a critical facility, right? So you sample the oil and take it to the lab for testing, right? To test for the oil quality or DGA gassing, right? So that basically it helps you to basically identify incipient faults that might come, right? And basically it helps you to take the required action to correct it. Right? Okay, so that is what this oil sampling plug is. So if you want to sample the oil, basically you remove the plug and basically drain, sample some oil and put the plug back. Then you also have an earthing terminal, basically that helps you to ground this to the substation ground grid through the ground rod, right? And during grade studies, right, ground grid studies, basically studies are conducted based on the level of short circuit current, right? The area of the substation and the area of the ground grid, right? So step and touch potential simulation is determined and to determine the required level, acceptable levels, and that itself helps to determine the size of the grounded rod that needs to be connected to the ground grid. Okay, so now let's talk about the advantages. I mean, definitely, its name speaks for itself, right? Combined instrument transformer. Combining the inherent capability advantages of the current and the voltage transformer. Right? Okay, so the first one is you are reducing the amount of instrument transformers in the bay, and that's perfectly true, right? Okay, because in a bay of a substation, right? Okay, you should have a standalone current transformer, high voltage current transformer, right? That is one equipment on its own. Then you should have a standalone voltage transformer. That is one equipment on its own. But if you are able to put all these equipment together in one enclosure. Basically, you've been able to achieve a reduction of the amount of instruments, transformers in a bay. And like I indicated, there are many bays. I mean, for bigger substations, sometimes you can have quite close to about 20 to 30 bays. So think about it. The amount of reduction of instrument transformers that you can achieve based on that. Next is material cost. Lower material cost, and that's perfectly true, right? Think about the amount of material cost and the amount of material that you put into a current transformer, a standalone high voltage current transformer, and also the amount of material and cost you put into a voltage transformer. And matter of fact, even sourcing, procurement, itself can also be a headache, where you are procuring the current transformer from a different vendor, you're also procuring the voltage transformer from a different vendor, But in this instance, you have just a single equipment that is basically providing all these capabilities, and functions, right? So you end up reducing material costs, procurement costs, staging costs, storage costs, also less space, right, in the substation. Remember, when you have a standalone or discrete current transformer, and also you have a standalone and discrete voltage transformer, they all take up space in a bay, right? And think about it, like I told you that, there can be big substations, that you can have like a 20 to 30 bays, right? Okay. So if you have a combo or hybrid instrument transformer that basically combines the attributes of advantages of the current and the voltage transformer in just one enclosure, basically you end up basically achieving a less space. Next is less installation costs, and that's perfectly true. Okay, think about the installation cost to install a discrete current transformer, the installation cost to install a voltage transformer, right? So if, let's say, it takes about 2 to 3 weeks to install this one through installation, pre-commissioning, commissioning, right? And likewise 2 to 3 weeks for this one, you can just use 2 to 3 weeks just for the combination of that, right? So that itself translates to about 50% reduction in installation time and cost and labor. And matter of fact, you can optimize and utilize that labor cost or labor to another place that is really needed, right? Next is substitution, less footprint, and that is also ties into space, right? Okay, so basically, think about it, the space that this occupies, the space that this occupies, right? You are achieving about 50% reduction in footprint. Next is maintenance costs. Yes, so think about it. You are scheduling maintenance for this one. You're scheduling maintenance for this one. You're putting a lot of labor for this one, putting in a lot of labor, materials for this one, right? The inconvenience to take an outage, right? But you can achieve that through just one, basically because of the combined instrument transformer and also installation in terms of structures, right? Because I mean, these instrument transformers come they are basically installed on structures. You see that if this is the instrument transformer, right? There are structures that basically gets it bolted to the substation compartment floor. So basically, you have less civil work, right? Because if you have a discrete instrument transformer, that is current transformer and voltage transformer, you have structures for this one. You also have structures for this one, but you're achieving 50% reduction in structures. Okay, so now let's talk about the last slide. Okay, so if you watch my video and you like it, and also, like I told you, this is my YouTube page. It has tons of learning materials, which is very good for a young engineer. A young engineer that is ambitious to develop himself, right? Okay, so you can go there and there are tons of materials. Just take your time gradually. Because you see, developing your career, you won't get it within a day, a week or so. It takes time, right? But it's up to you to be consistent in your learning. Yeah. So for the past 31 years of my career, right? Think about it. On a daily basis, I learn the technical material. I learn new things every day. Sometimes in the morning, I learn. In the evening, I learn. So think about it. So you wouldn't get it within a day, a week. It's gradual. Then you build up on it. You build up on it. You just have to be determined and be consistent in your learning. So, and also as a development engineer, there are many videos out there, right, that helps you to continuously develop yourself. And as an experienced engineer, sometimes we all need refreshers, right? Yes. And that is why we have yearly refreshers. You can't just go in there and whatever video that is there that helps you to refresh yourself, refresh your memory. Right? And as a consultant, sometimes we all need refreshers. So don't forget to subscribe to my YouTube channel. If you like this presentation, select the like button and share with your friends. Okay, share that knowledge. Very, very important. And thanks to YouTube, thanks to technology, it's these days, materials are available on the internet for you to learn and develop yourself. Comparable to many decades ago, where basically, hard copy books, and even to get books, sometimes, can be very difficult. So, but with technology has made things easier for us. So let's capitalize on this technology and learn to develop ourselves and have that confidence. Remember, it's more of once you learn on a daily basis, you develop yourself, you build that confidence, right? And there are many engineers out there, like I said, that don't want to develop themselves. And basically, if you don't want to develop yourself, what is it? You lack that confidence. You lack confidence, right? And you do all sort of things to basically survive, and which is not ideal, which is not ethical. So you want to shy away from that. Don't do it. Learn, right, on a daily basis. Develop yourself. Slowly build your confidence. With that, thank you so much for your listening ears, and look out for more videos coming up. Thank you.